All right, so this is the lab report information for the nickel sulfate hexahydrate lab. So essentially the spectroscopic determination of nickel. So a couple things that you need for the lab report. Page 1, you need the lab report form. Page 2, you need the graph, which is going to be your absorbance versus concentration right here that you can see. These concentrations are of nickel sulfate hexahydrate. Don't forget those units, which is molarity. And on your y-axis, the units are actually just going to be absorbance. And then, of course, you always want your title. Don't forget to make this as a scatter plot, and you're going to do this as a trend line so that you can add a trend line to it. And that trend line, which should be in the format of y equals mx plus b. So that should be your second page of your report. Your third page of your report are all of the calculations. So make sure you include those. And then the last page is going to be a carbon copy of just your data. So that's the lab report. That's what I'm expecting. So let's start by talking about how to get those concentrations for that nickel sulfate hexahydrate. So to start with, you massed out roughly 4 grams of the nickel sulfate hexahydrate. I'm going to add that in there so you can see that. And we need to figure out a concentration in moles per liter. So our goal is to end with moles per liter of this solution. So that means we've got to get from mass to mole. So of course we're going to do a periodic table conversion. So we go and figure out what the molar mass is, and you're going to find out when you add all of those together, it ends up being 262.9 grams of nickel sulfate hexahydrate per 1 mole of that large molecule. Put that up there. And thankfully from this, you're going to end up in terms of moles of your nickel sulfate hexahydrate. So the last thing that you have to do in order to get to molarity, which we know are in units of moles per liter, is we've just got to divide by the volume. So that first flask that you transferred those solid green crystals into was a 100 mil. So we would have to convert that to liters, which would be 0.100 liters. And that answer from that calculation is actually what's going to give you the concentration of that nickel sulfate hexahydrate, and that's for your standard 1. And I'm going to make a big note of that. That is solution or standard 1. Now remember, from standard 1, you made all of the rest of the solutions through something called dilution. So we're going to go to a different color to show that. And so now we're going to figure out what is the actual concentration for standard 2. And we're going to use an equation called the dilution of solutions equation is what I'll call it. And it is actually M1 V1 is equal to M2 V2. So you're going to take the concentration for standard 1. So that's going to come directly from here. So that concentration here, you're going to plug in right here. And then you're going to multiply that by the volume that you took. And according to the lab, for that first one, you pipetted out 30 mils. Again, we have to be in the right unit, so liters. So we pulled out 30 mils or 0.03000 liters from solution 1. And we want to know how much, what is the actual concentration, so M2, in the 50 mil that we made it in. So 0.05000 liters. And that, once we do that calculation, that's going to give us the concentration for standard 2. And that should be in moles per liter. We're going to do it again. So if we looked, for example, at standard 3 concentration, and we were to calculate that, we're still going to use that M1 V1 equals M2 V2. In fact, I'll go ahead and change it just to stay consistent, and we're going to do M1 V1 equals M3 V3 because you're going to use your concentration from standard 1 again. So you would plug that value back in here. And for this particular solution, for standard 3, I believe you took 20 mils, which converted to liters is 0.02000 liters, is equal to what we're looking for, which is the concentration of standard 3. And again, you placed that, you transferred it over into a 50 mil, so 0.05000 liters, and that's going to give us the concentration of standard 3. You're going to do the same again, but for the next one, for 4, you're going to put 10 there, and then you're going to keep going, and this is the number that's always going to change, and then you'll get a new concentration. So you'll get all those concentrations. You'll plot those against their absorbance, which you have right here, and that's going to get you to that curve. Now that you have that actual curve there, your absorbance versus concentration, you're going to use that information. That's why you need the trend line in order to figure out how much unknown we have. So to find out how much unknown you have, we're going to go to another page. And what we're going to have to do is you're going to have to use the y equals mx plus b from your graph. So you were given some sort of absorbance for your unknown. Let's say that absorbance was 0.28. So you would plug that value in here. Of course, you're going to have different values. You're not going to have mx plus b. You're going to have actual numbers there. And then you would solve this equation and find x, which will give you the concentration of nickel sulfate hexahydrate in your unknown. So I'm going to make a note of that in your unknown. So now that we have the actual concentration of nickel sulfate hexahydrate, we now need to go to the next part, which is to figure out how much nickel we actually have in that unknown. So remember, when we started this, we filled the actual flask, the volumetric flask, up to the 50 mil mark. So to start off with, in order to get to just moles, we're going to multiply by the volume of the flask that it was in. And so 50 mils would be 0.05000 liters. And that's going to get us to the number of moles of nickel sulfate hexahydrate. Because again, when you walked into the lab, you had a certain amount of the unknown, the green solution that was in there, and then you had to dilute up to the mark with DI water. Now again, now we finally have the number of moles of nickel sulfate hexahydrate. So in this next step, we've got to get that to just nickel. So we're going to do a chemical formula conversion, noting that for every 1 mole of nickel sulfate hexahydrate, that there are how many moles of nickel in there? So notice just 1 mole of nickel 2 plus in that whole molecule. And then in the last step, because again, we want to find the mass of nickel 2 plus. So for every 1 mole of nickel 2 plus, we know from the periodic table that we have 69 grams of nickel 2 plus. And then that, as we go through and we cross out our units, that allows us to then find that we have X amount of nickel 2 plus. And that finishes your lab.